We continue with mathematics examination practice questions. So prove that log x to the power n is equal to n log of x. So we're going to get this side of the equation, and so we'll just let n later. So let's say let a be equal to log of x to the power n. So if we want to express this in exponential form, well, what is the base for this logarithm? This logarithm is in base 10, and so to express it in logarithm, it becomes 10 to the power a is equal to this, and so that is 10 to the power a is equal to x to the power n. Now I don't want to have n as a power. Remember, we want it to go in front, and so what I'm going to do is I'll multiply this by 1 over n. What I've done on one side, even the other side I also multiply by 1 over n, and so what I'm going to have is 10 to the power a divided by n is equal to x. Okay, now that we have got x, then I'm going to convert back this into a logarithm. Well, when we are converting into a logarithm, this is the base, and then so it becomes log in base 10, okay, of this number x. It should be equal to the power a over n. That is how we convert into logarithms from exponential. So this, which was the power, becomes the answer. Now log in base 10, we don't show the base, and so this is just log of x is equal to a over n. At this point I can multiply everything by n, and so it becomes n log x is equal to this, and this cancels, is equal to a. But what is a? We know what a is. A is there. A is equal to this portion. So where there is a, we're going to put that back. So we are saying n log x is equal to, where there is a, we put log x to the power n. So we have proven. Alright, let's go to the next question. Express x squared plus x plus 1 in partial fractions. Now what we have is x squared plus x plus 1, divided by x plus 1, and then x squared plus 1 in partial fractions. Now the first thing we need to identify is this an improper fraction or not? What do you mean by improper fraction? If the degree of the numerator is equal to the degree of the denominator, or if the degree of the numerator is greater than the degree of the denominator, that is an improper fraction. What do we mean? If we multiply, if we expand this, x times this will be x to the power 3. So the degree of the denominator is power 3. The degree of the numerator, the highest power, is 2. So because the highest power on top is smaller than the one down, so this is not an improper fraction. So you can go on and decompose. This is going to be equal to a divided by x plus 1. We'll just get first the first factor here, x plus 1, and then plus, we'll write the next factor, which is x squared plus 1. Now whenever we have got a squared in the denominator as a factor, always on top we need to write something that is in the form bx plus c. Just something in the form, we need to also add an x if we have got a squared there. But if we don't have any squared, we just need to go direct and just add a b. Okay, that is very important, because if we just put a b here, then we are going to get wrong values. At this point we can proceed. So this is x squared plus x plus 1 divided by x plus 1. X squared plus 1 is equal to, I can merge this as a single fraction, so multiply this and this. Okay, so this is a x squared plus 1, and then multiply this and this, plus bx plus c x plus 1, and then divided by x plus 1 x squared plus 1. Now we can see that the two denominators are the same, so we just equate the numbers which are on top. So that is x squared plus x plus 1 should be equal to a x squared plus 1 plus bx plus c, and then x plus 1. Okay, now at this point I'm going to make this a 0. And how can we make that a 0? We can see that they are linked to this. So x plus 1, what should be the value x such that I find a 0 there? That should be a negative 1. So I'll say let x be equal to a negative 1. At every point I'm seeing x, I'm going to substitute a negative 1. This would be negative 1 squared plus negative 1 plus 1 is equal to a. This would be negative 1 to the power 2 plus 1. Of course, I know this would be a 0, and when 0 multiplies with this, everything will be a 0, so that part I'll just leave it out. So negative 1 squared is a 1. This and this will cancel out, so this would be 1 is equal to negative 1 squared is a 1. 1 plus 1, that is a 2, so I've got 2a. So that means a is equal to 1 over 2. Okay. So now that you found the value for a, let's go on and find the value for the others, b and c. So what I'll do is I'll expand this one which is here. So that is x squared plus x plus 1 is equal to a times x squared, that will be a x squared, a times 1, that is a, and then plus b multiplied by x here, that is going to be bx. That will be bx squared, because this is bx multiplied by x, and then b multiplied by 1, that will just be bx, and then c multiplied by x, that is going to be cx, and then c multiplied by 1, that is going to just be a c. Okay, at this point now I'll arrange like terms together. So this with a squared, I put it with that, so I'll factorize out a plus b, and then put x squared outside because it's common, and then I'll go to only those with x's. So we've got this and this, so that is b plus c, and then I'll put x. This is a constant and this is a constant, so I'll put those together, a plus c. Okay, so this with squared, the number in front should be equal to the coefficient there. So that means a plus b should be equal to the coefficient in x squared, that is a 1, and then b plus c is going to be equal to a 1 also, and then a plus c is also going to be a 1 because the constant here and the constant here should be equal. But we know the value for a is what? A is 1 over 2, so I'll say 1 over 2 plus b is equal to 1. So b is going to be 1 minus 1 over 2. So what will be the value for b? B is also going to be 1 over 2. And then to find the value for c, I can either use this or this, just n. Let me substitute where there is b. So that will be half plus c is equal to 1. So c is going to be 1 minus 1 over 2. 1 minus 1 over 2 is 1 over 2. I can just use the last one for confirmation's sake. Where there is a, if I put 1 over 2, and then where there is a, I put 1 over 2. 1 over 2 plus 1 over 2 is a 1. So confirmed. Okay. So now we can now go on and substitute our values. So where there is a, we are putting 1 over 2 divided by x plus 1. And then plus where there is b, we are putting 1 over 2 x plus where there is, we are also putting 1 over 2, and then divided by x squared plus 1. So what I can do is, we have got 1 over 2 divided by x plus 1. I can factorize it, a 1 over 2 here. I'll remain with x plus 1, and then everything over x squared plus 1. So at this point, because we have got fractions on top, just the denominators of the fractions on top, I'm going to take them down. So these two I'll take it down. So this will be 1 over 2 x plus 1, and then plus x plus 1 divided by these two I'll take it down. That will be 2 x squared plus 1. So we have decomposed in two partial fractions.